So at this point we have already fixtured the part. You'll notice if you're watching these videos sequentially that the length of this standoff has been changed to make sure that we have plenty of clearance. We have already called up our 3 by 50 millimeter probe using an automatic stylus system change, and the next move is to start our program. Now we are using the teach-in method here, which means we are not starting off with a CAD model. We're going to start off with the joysticks, and we're going to teach the machine as we go. In other words, we're going to probe some points, and then the CMM is going to follow those probed points. And we're going to add some other jazz into it as well, like some clearance planes, but largely we're just using the joysticks. So from square one, we'll come up to File and New, and this is called a measurement plan. So the first thing we want to look at here is on the computer screen, the CMM tab, Measurement tab, Characteristics tab, and the Features tab. So starting on the CMM tab, we have green bars for CMM settings and stylus system. We'll cover these in more detail in a future video. But basically, this means the machine, the CMM itself, is connected, and the software knows everything it needs to know about that. The stylus system is green because we have a stylus system in position on our sensor, and it has been fully calibrated. Notice it tells you the name of the stylus as well, 3 by 50 millimeter stylus. And we do have the capability of changing styluses in the middle of a program. So it's important to note that when you're capturing features using the teach-in method, as we're doing here, whatever stylus is active is the one that will be called up in the program. And if you do a stylus system change out from this stylus that we have here to that stylus up there in the middle of the program will actually generate an automatic stylus system change for you. So watch out. So we'll come over to the Measurement tab, and we're going to work top to bottom here. So base or start alignment is highlighted in yellow. That means that we have not fully defined this. So we'll click on that. We're going to accept all the defaults here in the Load, Create, or Change Base Alignment window, and we're just going to say OK. And then the base alignment window pops up, and notice that spatial rotation, planar rotation, X origin, Y origin, and Z origin are blank. So I am literally going to just start probing points. So notice that well, you can't really see it on the video, but there's a little orange button that's flashing here. I go to use the joysticks and they just beep at me and they don't do anything. I do have to hit the little lock button to be able to move. Notice also that my speed knob is set to full speed here. If you have this speed knob set to 5% or so, as I have it here, now as we go to move this around, it is limited to that maximum speed. Well, if I turn the speed dial all the way up, now the joysticks are allowed to move much faster. So when you're capturing these points, you can put this speed dial all the way up. As soon as you're done capturing the points, it's best practice to close that all the way back down, just so it doesn't take off on you if you do an automatic command. So speed dial all the way up. We are going to come over and we are actually going to start taking points directly on the part. I'm going to take 1 point here, 1 point there, and 1 point here. I will also minimize the in-person view so that you can see what effect that's having in the software. So I'm going to drive directly into the part, and notice that a features window automatically popped up. We're looking at point number 1. I'm going to lift up, move over, and touch point number 2, and notice what happens in this features window. It automatically turns this into 2D line 1. That's its best guess at what type of feature this is. Shows you a little preview on the graphics screen here, and we can see that at this time our base alignment is set to the machine's coordinate system, and the machine's coordinate system, x0, y0, z0, is where the machine was when we homed it out initially. Now we didn't cover that in this video, but the machine goes all the way up to this position here when we home it out, so x0, y0, z0 is way up in that corner. And the purpose of this alignment that we're creating right here, this base alignment, is we are going to bring our coordinate system from the machine's coordinate system over to meet the part. So that's why there's so much distance in between the two right now. So we've touched 2 points. It turned into 2D line 1 automatically. You can ignore the rest of the window for now. Go take the third point, and we should see that that turns into a plane. Now if we don't see that automatically recognized as plane 1, then that means we took a bad hit. If it calls that a circle or something like that, you probably took a hit from the wrong direction, like you were moving left to right instead of from up to down. So we're paying attention to make sure that says plane 1. We can look on our screen here and we can see the distance between home position and the plane we just created, so that all looks good. And in our features window, if we simply hit OK, it closes the features window automatically. It automatically populates spatial rotation and Z origin. We'll cover much more on the theory about this in a separate video. It also may modify your pull downs for your axes here for you, depending on which machine axis that fell closest to. Now the good news is Calypso is very good at guessing at this, so a lot of times you can just leave that alone. In some situations, you have to modify that. In this case, we're good to go. The biggest mistake that I see in this process is not hitting OK on the feature window. Right? So I hit OK on the feature window and that populated this and this. A common mistake is to simply continue taking all of your other points. The next point that I'm going to take will be, I'll touch a line on the front of the part, and then I'll touch a point on the left side of the part, and that'll put my coordinate system right here at the lower left. Now I am intentionally going to make a mistake here when I do this, and I'm going to touch a point and a point on the front, and I won't hit OK on the feature window, and I'll touch a point on the left side as well, and you'll see that that will create some bad results. So let's go do it. I will drive over and take a point on the front line of the part. Notice that the features window pops up and it says 0.1. I'll take another point on the front line of the part. We can see it shows up in the graphics view here. And notice that we have exactly what we want. It's modified to 2D line 1. At this point, I should say OK. But instead, I'm going to forget that. And I'll come over and touch a point on the left side of the part. And notice how that has created circle 1 now. That should be a red flag right there. It's like, circle 1. I was expecting a plane, a line, and a point for this alignment. How did I end up with circle 1? Well, you touched too many points, and we want to get rid of one of those points. So we could come in here to strategy, and we could click on the last probing point. When you click on it, it highlights in purple, and you could just right-click and cut that out of there and say OK. And now we're back to 2D line 1. We say OK, and notice we're back at our base alignment window. Planar rotation has automatically selected the axis it wants, and it set that to 2D line 1. And it also set our Y origin to 2D line 1. And notice our little preview here of our coordinate system. Looks like it's moving in space, and our initial coordinate system is still way up here in space. So it's good that we see this preview coming down to meet where our part is. Now the last point is, we want to come over and fill out this X origin dialog. For this, we want to just drive into the left side of the part. Again, the feature window pops up automatically. It prompts as 0.1. We say OK, and that populates our X origin here. Notice also that the preview gnomon or XYZ icon here has updated itself to the intersection of plane 1, 2D line 1, and 0.1. And in the real world, that is this location right here, or something close to it. Now, we want to verify this in the real world. So switching back over to the software, notice that in my stoplight window over here, my X, Y, Z readout is X 8-inch, Y minus 14-inch, Z minus 18-inch. And that makes sense because as of right now, we are looking at the CMM's system. So that's our distance from home position. Well, initially that was helpful because we had no part coordinate system set up. But now that we have a part coordinate system set up, that's no longer helpful. Let's switch over to base alignment. And you can think of your base alignment like your part alignment, basically. Now, when I hit the pull down, I see no change here, and that's because I haven't actually saved this base alignment yet. I should hit OK here, and notice that our numbers jump. Now we're much closer to X0, Y0, and Z0 here. If we switch back over to CMM system, we have the same numbers we had originally, 8, minus 14, and minus 18. Looking at our base alignment, now we have something close to 0, 0, 0. So it's always wise to check your coordinate system. And to do that, you move over to the origin, within plus or minus a half inch. If you were up a little bit, that's fine. It doesn't have to be perfect. If you're a little off to the right side, that's fine. But the essence here is that we're making sure this XYZ readout right here is somewhat close to what we see in the real world. So you have to check more than just your location. So there we check the location of the X, the Y, and the Z all at once. And now we need to check the orientation. We need to make sure that when we drive down the X-axis in the positive direction, does our X-axis here actually drive in the positive direction? Now, why would that be wrong? Well, looking at your gnomon icon here, if that was rotated 90 degrees off, well, then when we're driving down the X-axis, it might think we're driving backwards down the Y-axis. And that could very easily happen if one of these was switched, right? If we accidentally aligned to our Y-axis here, well, that's so far off, it's not even able to calculate it. The point being, it is conceivable that this could be rotated off a little bit, and that's what we're checking here. So right now, I drove positive down the X-axis. I see my X-axis is some positive number, and I see that my Y and Z are relatively unchanged. So my next move is to move back to the origin. So I know my X-axis is pointing in the correct direction. Now I'll drive down the Y-axis in the positive direction, and I'll just make sure over here on my stoplight window that my Y coordinate did go in the positive direction, which it did. So again, if the X was moving instead of the Y, or if the Y was moving in the negative direction, that would mean this gnomon is set up incorrectly, and our coordinate system set up incorrectly, and we should stop here and start over before we try to build a house on a bad foundation, so to speak.